Lecture 2 on Chapter 1 is starting to make decisions based on this decision rule. Decision rule is a formal rule that we state well ahead or well in advance of gathering our evidence. And this formal rule is going to be based on the data. That data is going to help me make my decision. And the formal rule based on the data tells me when to reject the null. It tells me when this happens, you're going to reject, and that way we all do the same thing. The direction of the extreme. The direction of the extreme, well, if I look at a picture, large values, these values are what we would constitute as being extreme. In other words, if I landed in this region, that would be where my alternative would be, and notice that is on the right. So when we talked about directions of tests, that would be a right-handed test because my alternative, I'm looking if I'm on the right or if I am greater than. Smaller values for the direction of the extreme then would be on this side, and that would be on the right. So I'm just kind of looking at this center and asking myself, where's that extreme value? If I get that, that's pretty extreme to be happening if my null is true. So therefore, I'm going to look if I land in this area or not. So we have these regions called the rejection region and the acceptance. If I get values that are in the rejection region, they are more likely to occur under the null. So the rejection region means data in this rejection region is more likely, notice I can't say for sure, but more likely to occur under the alternative. So in other words, if I land, or my data comes and it lands in this region, I'm going to reject. The acceptance region is the other area. In here, the data that I collect, or the values, are more likely under the null. Therefore, I accept the null. So just looking at these two pictures, if I was to gather my evidence and I land in this region, that's where I would accept my null. It's either accept my null or reject my null. You don't use the word alternative. It's either decision accept or reject the null. So if I land in this region, there's my cutoff, that's where I'm going to reject. So we make up this region well in advance, and we call it a critical value. It's the cutoff value. And it's cutting off the accept from the reject. So let's go ahead and look at a couple examples here. Here's bag A and bag B again, the same bags that we worked on earlier. The decision that we've made well in advance is if I grab out a $60 voucher, assuming that this is my null, if I grab out a $60 voucher, that is when I am going to reject and say the bag I'm pulling for is not my null, it is my alternative. So my rejection region, if I look at this, if I get values on this side, that's when I'm going to reject. If I get values on this side, I will accept. The right and left of $60. So my rejection region is on my right, on this side. The critical value is the $60 voucher. Now, the chance of a type 1 error, probability. If I grab a $60 voucher, I will reject. There is one $60 voucher in this bag of 20 vouchers. Figuring that out, that is a 5% error. I have a 5% chance of grabbing a $60 voucher out of that bag. If I grab out of that bag the $60 voucher, from our original decision rule, it's telling me to reject when I should have accepted. So I have a chance of making an error based on this decision. Let's try another one. Same bags, now I'm looking at a $40 voucher. So looking at the $40 voucher, the $40 voucher is located right here. So when I look, if I get anything 40 or on this side, I'm going to reject. So this is where I accept that it is my no. So again, my rejection region is on the right. The critical value is the $40 voucher. And the chance of a type 1 error, how many vouchers are 40 and on this side? Counting them up, there are 4 out of the total in the entire bag, which are 20, which figuring that out, that's a 20% error. A bigger chance of making a mistake. Let's look at a couple different bags here. The decision rule, let's suppose I'm going to reject if I pull out the $1 voucher or anything less. Looking here, here is my critical value. It's the $1. That's where I make a change, either to accept or reject. Now, looking at this, if I pulled from this area, I would be rejecting. If I'm on this side, I'm going to accept that this is my null. Notice if you compare, there's more $5 bills in the null than there is in the alternative. So it's on my left where I reject. So we call that a left-handed test. The chance of a type 1 error. There is one voucher that's going to cause me to make an error, and that's if I pull out the dollar from the null. The decision told me to reject. I could pull that $1 out. There's one of those $1, and in this bag there are 15 vouchers. So if I wanted to find a percent, and that's a pretty small percent. Let's try another example here. My decision rule here is, I'm going to kind of look at $2. I don't have very many on that side, which is on my left, and I don't have very many on my right. Now, this is just arbitrary. I could have picked the $1 and the $10. I'm going to go with the 2 and the 9. So my decision rule is to reject if I am less than or equal to $2 or greater than or equal to $9. So my rejection region, I could reject if I land over here and grab out the 2 or the $1, or I could reject if I land over here. This is where I'm going to accept. So my rejection region is two-sided, to the left and to the right. I have two critical values, the $2 and the $9 voucher, and chance of a type 1 error. Well, how many vouchers do I have which would cause me to make a decision that would be wrong? There are 6 in this bag of 30 vouchers. If you count all those X's, there are 30 of them, which reduces to 1/5. So when I figure a percent is a 20% chance. Now, I could narrow this if I refine my decision rule. 20% chance of an error is pretty big. If I refine and use these as my decisions, change it to be less than 1 or greater than or equal to 10, my critical values are 1 and 10, and here it would be 2 out of a 30 chance, or 1 out of 15, which is a much smaller chance of an error. We want to reduce the chance of making that error.